Imagine a world, a sister planet to our own, that once inspired dreams of a lush paradise, a twin Earth teeming with life. Envision explorers setting foot on its verdant surface, breathing in the fresh air and discovering new wonders. But the reality is far more sinister, a stark contrast to those hopeful visions. It is in reality a vision of hell, Venus. For centuries it was the morning and evening star, a celestial jewel admired by civilizations across the globe, a brilliant beacon in our sky, a constant presence that sparked curiosity and wonder. But beneath its dazzling clouds, a veil that hides its true nature, lies a planet more extreme, more hostile than we ever imagined, a world where survival seems impossible. Venus's atmosphere is a crushing, toxic blanket, a suffocating shroud of noxious gases, over 90 times Earth's pressure, the equivalent of being nearly a kilometre beneath the ocean's surface, mostly carbon dioxide, a greenhouse gas that traps heat with terrifying efficiency. This runaway greenhouse effect traps heat, creating a furnace-like environment, making the surface a blistering 465 degrees Celsius, hot enough to melt lead. Hotter than Mercury, the planet closest to the Sun, a truly hellish temperature. The sky glows orange-yellow, a perpetual twilight cast by the dense atmosphere. And the clouds are laced with corrosive sulfuric acid, a constant rain of acid that erodes the landscape. These clouds reflect sunlight, making Venus shine brightly, a deceptive beauty that hides the horrors below. But hide a landscape shaped by violent forces, a testament to the planet's turbulent past and present. Vast volcanic plains, stretching for hundreds of kilometers, a sea of solidified lava. Towering mountains, remnants of ancient geological activity piercing the toxic atmosphere. And bizarre geology define its surface, strange and alien formations unlike anything found on Earth. Venus guards its secrets jealously, a world shrouded in mystery and intrigue. Behind an impenetrable curtain of cloud and heat, a barrier that has challenged scientists for decades. Telescopes and rovers, our robotic emissaries, can't easily reveal its mysteries, their vision obscured by the planet's thick atmosphere. To see Venus, to truly understand its nature, we needed new technology, innovative solutions to overcome the planet's formidable defenses. Ways to pierce the clouds and map the world below, to unveil the secrets hidden beneath the toxic veil. The story of Unveiling Venus is a testament to human ingenuity, a chronicle of scientific breakthroughs and relentless determination, and our relentless drive to explore, to push the boundaries of knowledge and understand our place in the cosmos. Welcome to the true face of our fiery neighbour, a world of extremes and a challenge to our understanding of planetary science. For most of human history, Venus was simply a bright point of light in the sky, a celestial beacon. Ancient civilizations, from the Babylonians to the Mayans, meticulously tracked its movements, weaving it into their mythologies and calendars. They saw it as a goddess, a harbinger of dawn or dusk. But its true nature remained a mystery, hidden behind a veil of shimmering light. The first real clues about its true nature, the first hints that Venus was far more than just a pretty face, came from the pioneering work of radio astronomers in the 1950s, who were just beginning to probe the universe with these new tools. They detected unexpectedly strong microwave emissions emanating from Venus, suggesting surface temperatures far beyond anything imagined, scorching even. The long-held dream of Venus as a tropical twin to Earth, a lush paradise teeming with life, quickly faded as NASA's Mariner 2 spacecraft made its historic flyby of Venus in 1962, marking humanity's first close encounter with another planet. The data it sent back definitively confirmed the planet's extreme heat, revealing a hellish environment. Mariner 2 also revealed the surprising lack of a global magnetic field around Venus. Without a protective magnetic shield, Venus's atmosphere is directly exposed and vulnerable to the constant bombardment of the solar wind, a stream of charged particles from the Sun. Mariner 10, during its mission in 1974, provided us with our first close-up photographs of Venus, revealing just a seemingly featureless cloud-covered sphere. But ultraviolet images captured through special filters revealed a dynamic, swirling atmosphere, a world of constant motion hidden from our direct view. These images showed super-rotating clouds racing around the planet at incredible speeds, far faster than the planet itself rotates. These early missions answered some fundamental questions about Venus, but, as is often the case in science, they raised even more. We knew Venus was incredibly hot and shrouded in a thick, fast-moving atmosphere. But what secrets lay hidden beneath those swirling clouds? Was the surface a rugged landscape of towering mountains, a vast flat plain, or a geologically active world dominated by volcanoes? To find out the answers, we needed to go there, to send probes that could withstand the harsh conditions, or develop new technologies that would allow us to see through the dense, opaque veil of clouds. The stage was set for a new era of exploration, a deeper dive into the mysteries of our veiled sister planet. Venus's secrets were still waiting to be uncovered, promising a wealth of scientific discovery. While NASA conducted flybys, gathering valuable data as they zipped past Venus, their focus was often split between multiple celestial targets. The Soviet Union, however, had a singular, ambitious goal: to not just observe Venus, but to land on its surface and send back tangible proof of their achievement. Their Venera program, dedicated entirely to Venus, faced a series of crushing failures in its early years. Many probes were lost during launch or succumbed to the planet's harsh environment before even reaching the surface. But the Soviet engineers were undeterred. They meticulously analyzed each failure, learning from their mistakes and refining their designs. Their persistence, fueled by national pride and scientific curiosity, would eventually pay off. In 1970, after numerous attempts, Venera 7 achieved the impossible, becoming the first spacecraft to successfully land on another planet and transmit data back to Earth. It survived for a mere 23 minutes in the hellish conditions of Venus, enduring scorching temperatures and immense pressure, a testament to the ingenuity of its creators. Following in its footsteps, Venera 9 and 10 soon followed, sending back even more valuable data, including the first grainy images from the Venusian surface. These images revealed a rocky, desolate landscape bathed in a dim orange light, a stark and alien world unlike anything seen before. These landers, however, only provided tiny glimpses of the Venusian surface, offering a limited perspective on the planet's overall topography. To truly understand Venus, to see the whole planet in its entirety, a different approach was needed. NASA's Pioneer Venus project, launched in 1978, aimed to do just that, employing a combination of probes and an orbiter to study the planet from multiple angles. Multiple probes were deployed into the Venusian atmosphere, each equipped with instruments to profile its composition, temperature and pressure at different altitudes. Meanwhile, the orbiter circled Venus, using radar to penetrate the dense clouds and map the surface below. Radar technology was crucial, as it could pierce through the thick, opaque clouds that perpetually shroud Venus, something that optical telescopes could never achieve. By bouncing radar signals off the Venusian terrain and measuring the time it took for them to return, scientists could accurately determine the height of various surface features. Over the course of 4 years, Pioneer Venus painstakingly built the first global topographic map of Venus, revealing its hidden secrets. The resulting map was blurry and low resolution by today's standards, but it was a revolutionary achievement, providing the first comprehensive view of the Venusian landscape. It revealed the presence of vast highlands towering above the surrounding plains. It also showed expansive lowlands and relatively flat plains stretching across the planet's surface. Venus was not the smooth, featureless sphere that some had imagined. Its hidden face was slowly emerging from behind the veil of clouds, revealing a complex and varied topography. The world beneath the clouds was beginning to take shape, offering tantalizing clues about the planet's geological history. But despite the groundbreaking achievements of Pioneer Venus, many details remained hidden, obscured by the limitations of the technology. To truly unveil the secrets of Venus, we needed sharper eyes, more powerful instruments, and a more sophisticated approach. The next chapter in the exploration of Venus would change everything, ushering in a new era of discovery and revealing the planet in unprecedented detail. The Magellan mission was designed to map Venus in unprecedented detail. Launched in 1989, Magellan used synthetic aperture radar to see through the clouds. As it orbited, Magellan sent radar pulses to the surface, creating detailed images by combining echoes from multiple angles. This technique ignored the thick clouds, revealing the landscape below. Arriving in 1990, Magellan spent 4 years mapping Venus strip by strip. The data was assembled into a global mosaic, showing the planet's true face for the first time. The resolution was 10 times better than before. Features as small as a football stadium became visible. The blurry world snapped into sharp focus. What we saw was more alien and fascinating than anyone had imagined. Venus was unveiled. Magellan's data revealed Venus as a volcanic world. Over 80% of its surface is covered by vast lava plains, evidence of massive volcanic floods. Unlike the cratered Moon or Mercury, Venus has few impact craters, all large and pristine. Its thick atmosphere destroys smaller meteors before they reach the ground. The craters are randomly scattered, suggesting the surface is uniformly young, about 500 to 700 million years old. It's as if the planet was resurfaced in a cataclysmic event. This hints at global volcanic upheaval, unlike Earth's gradual change. Magellan found thousands of volcanoes, from small shields to giants like Martmons. Some lava flows appeared fresh, and surface changes hinted at recent eruptions. Venus is not a dead world, it's geologically alive. The surface tells a story of violent renewal. The planet's youth is a mystery. What caused such dramatic change? Magellan revealed bizarre features unique to Venus. The most striking are coronae, huge circular structures formed by upwellings of hot mantle material. As plumes push up, they create domes that eventually collapse, leaving fractured rings. These features show Venus's mantle is dynamic, but its crust is stagnant. Magellan also found pancake domes, flat, circular volcanic domes formed by thick, slow-moving lava. These domes, up to 25 kilometers wide, dot the plains in clusters. Their shape and size are unlike anything on Earth, shaped by Venus's heat and pressure. These features are clues to Venus's unique geology. The planet's surface is a gallery of alien wonders. Magellan's map let us compare Venus and Earth. 2 planets, 2 destinies. Earth's crust is broken into moving tectonic plates, driving geology and climate. Venus's crust is a single stagnant shell, no plate tectonics. Without moving plates, Venus's heat builds up, released only in massive volcanic events. This stagnant lid also traps carbon dioxide. On Earth, plate tectonics recycles carbon, regulating climate. Venus has no such system. CO2 from volcanoes accumulates, fueling a runaway greenhouse effect. Any ancient oceans boiled away, water vapor accelerated the heating, and hydrogen escaped to space. Venus became a cautionary tale, a world where climate regulation failed. 2 similar planets, but one became a furnace. Understanding Venus helps us understand Earth's delicate balance. The differences are profound and vital. Magellan answered many questions, but left deeper mysteries. Did Venus once have oceans? The deuterium to hydrogen ratio hints at lost water, but how much? Is Venus still volcanically active? Magellan saw hints but couldn't confirm eruptions. Why did Venus and Earth diverge so dramatically? Was it distance from the Sun, lack of a magnetic field, or stagnant crust? To answer these, we need new missions, ones that can analyze rocks, probe the atmosphere, and map the surface in even greater detail. Magellan gave us a snapshot. Now we seek the story. The quest to understand Venus is far from over. After decades, humanity is returning to Venus. NASA's Veritas and Da Vinci missions will map the surface in high resolution and probe the atmosphere. Veritas will search for signs of active geology and reveal the composition of surface rocks. Da Vinci will descend through the atmosphere, sampling its chemistry and imaging ancient terrain. These missions will help unravel Venus's history and its runaway greenhouse effect. Understanding Venus is crucial for understanding Earth's climate and fate. Venus is a warning and a mirror. By exploring our sister planet, we learn more about our own.